Welcome to Two Projects. In this video, we are going to explain the project Phishing Detection using Deep Learning. Before diving into the execution, let me give you an overview of the project. So, the project aims to develop an effective phishing detection system using deep learning techniques. Phishing attacks where malicious actors pose as trustworthy entities to steal sensitive information pose a significant threat to data security and user trust. Traditional detection methods reliant on statistic rules struggle to adapt to evolving attack strategies. So, this project seeks to overcome these limitations by employing deep learning models capable of learning and recognizing new phishing patterns. Traditional methods like blacklists or whitelists, heuristic approaches, and machine learning have shortcomings such as inability to detect new sites or high false positive rates. But deep learning models such as LSTM, MLP, DNN, and CNN offer a promising solution in capturing complex relationships within data. So, the project involves data import, exploratory analysis, pre processing, and model training. Performance evaluation metrics guide the selection of the most effective model, and the project's beneficiaries include individuals, organizations, financial institutions, and cybersecurity professionals aiming to enhance data protection and cybersecurity resilience. So, this is what happens in this project. Now, we look at the software and hardware requirements to execute the project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So we have trained long short-term memory, multi-layer perceptron, deep neural network, and a CNN model that is convolutional neural network. We have compared the performances of these models using different performance metrics like accuracy, precision, recall, and F1 score. And we have observed that long short term memory has outperformed for training and validation. So we have deployed LSTM into the Flask web application. We will be executing the project using Flask framework. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is archive folder in which I have required phishing dataset. So these are the columns. So this dataset comprises various features associated with URLs, including indicators like domain registration length, presence of HTTPS, and website traffic statistics. And the class column is the target variable indicating whether a URL is classified as phishing or legitimate, facilitating supervised learning for phishing detection. So we will be training the deep learning models on this dataset. And this is models folder in which I have model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes coded in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is phishing URLs text document in which I have test cases, test URLs which will be used during the execution. This is signup.db file. This file is the database file used to store user information. So it stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path of the code folder and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first, fill in all these details and click on sign up button to register. And if we already have account, we can directly log in by clicking on the sign in link. As I'm already a member, I'm clicking on the sign in link. Here we have to give our credentials, username and password. I'm giving mine. And click on sign in button. So it has redirected us to the phishing detection page. So now we have to enter any URL here and the application will analyze the page to determine if it is phishing or legitimate. So as I mentioned earlier, I have test cases in this phishing URLs text document. So these are test URLs I have. First, I'll try giving the first URL. I'm copying it. I'm pasting the URL here and click on check here button. So it will take some time to load. So this is the given URL and here we can see the result, that is the website is 94% safe to use. So the application will go through the website and it will analyze if the website is safe to use and it will give us the percentage telling us how safe the website is to use. So this website is only 94% safe to use, and if we still want to use the website, we can click on still want to continue button. So the application will redirect us to that website. We'll try giving another URL. Click on fish detect link here. This time I'm giving this URL. I have copied the URL and I'm pasting it here. Click on check here button. It will take some time to load. This is the URL I have entered and here we can see the website is 100% safe to use. So this website is 100% safe to use. If we want to view the website, we can click on still want to continue button. So it has redirected us to that website. We'll try giving another URL. Click on fish detect link. This time I'll try giving this URL. I'm copying it. I'm pasting the URL here and click on check here button. This is the given URL and here we can see the website is 98% safe to use. So the application will go through the website and it will analyze the website and it will give us this percentage telling us how safe the website is to use, and this website is only 98% safe to use. If we want to view the website, we can click on still want to continue button. We'll try giving Flipkart's URL. I'm searching for Flipkart here. I'm giving this URL. Give the URL and click on check here button. It will take some time to load to give us the results. This is the given URL, and here we can see the website is 100% safe to use. So this website is 100% safe to use. If we want to view the website, we can click on still want to continue button and it will redirect us to that website. We'll try with one last case. Click on fish detect link. This time I'm giving this link. I have entered the URL. Now click on check here button. It will take some time to load. This is the given URL, and here we can see the website is only 94% safe to use. So the application will go through the website and it will analyze how safe it is to use, and it will give us this percentage telling us how safe it is to use. So if we still want to view the website, we can click on still want to continue button and the application will redirect us to that website. So now we'll look at the graphs plotted. Click on the graphs link here. So here we can view all the visualizations made. So this is sample outcome graph which displays the distribution of the data. So in this graph on x-axis I have labels and on y-axis I have their count. So here 1 represents legitimate data and -1 represents phishing URLs data. So we can see there are more number of cases with legitimate. This is correlation matrix graph which tells us if two variables are correlated or not. This is accuracy scores comparison graph. So in this graph on x-axis I have algorithm names and on y-axis I have accuracy scores. Similarly, this is precision scores comparison graph, this is recall scores comparison graph, and this is F1 scores comparison graph. So these are the graphs plotted. Now click on sign out. So the project creates a robust phishing detection system using deep learning, improving accuracy and adaptability over traditional methods. This system effectively identifies phishing attempts, enhancing cybersecurity and protecting sensitive information for individuals and organizations, leading to safer online environments and increased user trust.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.